Hello, in this video we'll be starting to learn about something called structs. Now, in C++, we have something called primitive types or simple types. Those kind of types are integers, or rather ints, floats, doubles, chars, etc. And the reason why those are called simple or primitive types is one, because they come inherent with the language, which is why they're called primitive. They automatically come from the language, which in this case is C++. And they're called simple because they only have two values. One, which is the address of the variable, and then two is the value of the actual variable. For example, an integer a can be equal to 5. In this case, a will have an address and it will also have a value, which is 5. This is a primitive or simple type because it only has those two things. However, in C++, we can create our own types, like an integer or a float or a char, and that will be called a complex type or user-defined type. Those are both sort of the same term that mean the same thing. So, if you ever hear about someone saying a complex type or user-defined type, that's what they're talking about. We are talking about creating our own type, like an integer, like a char, etc. And the reason why it's called a complex type is because it will be able to do so much more things. Our complex type can hold multiple variable or multiple values. It can hold its own variables with its own type with their own types. It can have its own functions, and etc. It can do many things. That's why it's called complex, because it's not simple. Now, the way you start with these user-defined types is with the struct keyword. The struct keyword tells the compiler that we are going to be creating our own type. It's kind of like when you write int my variable. In this case, with struct, we give it a name. In this case, we can do my struct, and then we give it these curly braces just to signify that this is what's going to be inside of our struct. And you'll notice that I don't give this a value, and it's because this is going to be a type. It's not going to be a variable like how we do with integers or floats or chars or etc. This is going to be a type. It's going to replace something like int or double or char or etc. And so I know that some people can get confused with the difference between an enum and a struct, and that is the difference. So the struct is going to be able to hold multiple variables of different types instead of just integers, and it's going to be able to we're going to be able to define our the functions for this type specifically. Like, for example, if integer had its own specific types, we're going to be able to do that for my struct. And again, it's called a complex type because integer doesn't have its own functions, but we can define my struct to have its own functions, which is why, again, it's called a complex type. So let's go over how to get started with this. So in the struct, we're going to be able to declare our own variables like how we do in, for example, another function, where if we do int a equals 5, or int b equals 4 or 3, we're going to do the same thing in my struct. So in here we can do int m underscore a equals 5, and then int m underscore b equals 4. And so whenever we create a new type, or rather a new variable with this type, it's automatically going to have these integer values assigned to it. And so it's not going to happen only once. These aren't being initialized only once. They are being initialized every time we have a variable of the type my struct. So unlike in a normal function where we declare these variables, which are going to be initialized only once, these are going to be initialized every time we create a variable of type my struct. So how do we access these variables inside of my struct? Well, we use something called the member access operator. The member access operator is going to be a period operator or period symbol it's going to tell the compiler what we're getting and from where. So let's take a look at that. So first we're going to create a variable of type myStruct, because again, remember, myStruct is going to be a type. It will be something like you would do with an integer, a char, a float, where you declare a variable using this type, and we're going to give it a name. Let's just say var, and then we can do cout var, and then here's that period again. It's called the member access operator, and then we can choose whether we want to get the member A or member B. And so the reason why I say member is because these variables inside of my struct, these are called members, and a common practice when you're declaring these members is to name them with or with an m underscore. This just helps us as programmers whenever we're working more with variables and assigning to them inside of the struct, which we'll cover later. It's just good practice to ensure that we are assigning to the right variable. This lets us the programmers know that we're trying to access this variable, and you'll see what I mean by that later in the class. It's a better way of disambiguifying just what we're trying to access. So these are called members because they are a member of the type, which is myStruct. So these are called member variables. And so here we want to access, just say member A. All right, and let's go ahead and do that now. So I'm going to go ahead and run this. And then we can see here that we have our value 5. And so we can see here that without the C++11 extension, I'm running C++98 right now, that it has an issue with the way we're declaring these or defining these. You don't have to worry about that for now. If you it was just a long time ago, there was just a different way of initializing member variables. So if you're as long as you're using C++11 or later, then you don't have to worry about these warnings if you do get them. But anyway, so what this is doing, again, let's break this down, is we're gonna take the member m underscore a, right? We're using the member access operator. We're gonna take the member a, and where we're taking it from is var, all right? And so again, this period is the member access operator. It's telling the compiler where we're getting something from, all right? And if we wanted to change this, we can. Let's just say we want var.ma to be equal to 10 now. We can do that. And then now we can see the member is equal to 10, and that will remain consistent in this variable only. It won't actually change it for every variable that has that is of type myStruct. And we can see that by if we do myStruct var2, and then we do var2 m underscore a, we can see here that it goes back to 5, because again, we're only changing it for this variable. We're not changing it for this variable. It's just that these variables right here are going to be the default variables that every variable are going to have. All right, so it's a little difficult to comprehend that a variable has its own variables inside of it, but just trust me, with a bit more practice and just working with structs a bit more, if you're having a hard time understanding that, it will become easier. Just remember that. So with a struct, whenever you declare a variable with the type of the struct, it will have its own variables inside of it, and you can access those variables just like how you're doing with a normal variable through the member access operator.